students, good morning. In last session, we discussed about structure of atom. Today, in our session, we are discussed some more important and easy chapter of a 10th class is chemical bonding. Chemical bonding. Let us start the chemical bonding lesson. Write down the key points of this chapter. Write down, children. Okay, in late 19th century, the scientists are discovered or known three types of forces, that is magnetic force, gravitational force and electrostatic force. The scientists also known in that period electrons, protons and electron protons are discovered in those days. They believed that the electrostatic force of attraction between electrons and atoms of molecules. Okay, in periodical table observed molecules or atoms. What do you observe? All atoms are occurred in free state or combined form. No, all elements are not occurred in free state. Some observed hydrogen H2, nitrogen N2, oxygen F2, water H2. Here you observe hydrogen atom combines another hydrogen atom to form H2 atom. Like that, oxygen also, one oxygen combined with another oxygen and form O2, and two hydrogen atoms combine one oxygen atom and form water. Here one nitrogen is combined another nitrogen and forms N2 atom. Here all elements are in occurred free state. That's why here is the doubt arises to scientists. Then the investigation started and discovered the bond is there in between of elements or atoms. Then the chemical bond is developed by the such a type of doubts. Okay, assume this is an atom. This is another atom. Assumed A atom and B another atom. There is some distance between A and B atoms. There is a attraction force between electrons of A atom and nucleus of B atom. There is a attraction between electrons of A atom to B nucleus. There is an attraction force between electrons of B atom to nucleus of A atom. To understand, children, assume this is A atom, this is B atom. Both are certain distance. Here, the attraction force between these A atom electrons on B nucleus. B electrons, A nucleus. There is attraction force is there. Okay, now they are closer. A atom and B atom put very close, comes very closer. Then the electrons of A atom and B atom are repel each other because of they are liked atoms. They are liked charge or repel. Liked charge or repel. Unliked charges are attracted. Unliked charge is attracted. Liked charge are repel. Unliked charge are attracted. Whether in this case they are attracted. When atom of A and B come very closer, then repulsion will take place because of electrons of A atom, electrons of B atom, both are minusly charged. That's why they can repel. They can repel. Okay. Observed some atoms configuration: helium, neon, argon, krypton, radon, xenon. These are all 8A group elements. These are all 8A group elements or 0 group elements. These are known as noble gases or inert gases. These are all known as noble gases or inert gases. Except helium atom, both except helium atom, remaining elements all consist of 8 electrons in their outermost shell or contains 8 electrons in the outermost shell. Every atom attains to acquire the electronic configuration of inert gases. Every electron is try to attain the electronic configuration of these neon, argon, krypton, xenon, radon. That means noble gases electronic configuration. Now observe the practical behavior of elements in a periodical table. In periodical table, we have first A group elements, second A group elements, third A group elements, fourth A, fifth A, sixth A, seventh A, eighth A. Eighth A. Okay, let us observe some elements. Let us observe some elements. Okay, here observe sodium. Sodium atom. Sodium electronic configuration is 2, 8, 1. That means the atomic number of sodium is 11. The atomic number of sodium is 11. Electronic configuration of sodium is 1s2, 2s2, 2p, 6, 3s1. For your understanding, I will write like this: 2, 8, 1. Are you understand, Nana? Okay, like that. The electronic configuration of sodium is like that. Here, sodium wants to try to attain nearer electronic configuration. To sodium, nearest inert gas is neon. Neon electronic configuration is like this: 2, 8. To attain the neon electronic configuration, sodium lose one electron. It is ready to lose to attain nearest inert gas. That is why sodium loses one electron easily. Sodium loses one electron to form Na plus. It forms positive ion. It forms positively ion. To attain every electron, every atom, every element attain the nearest electronic configuration. It wants to attain the nearest electronic configuration. Nearest electronic configuration of inert gases. Now let us observe second year group elements. This is a first year group element. Let us observe second year group element, that is magnesium. Magnesium electronic configuration is 12. Its atomic number is 12. Its atomic number is 12. Its electronic configuration is 2, 8, 2. Magnesium is ready to lose 2 electrons to attain the inert gas of nearer inert gas of helium. Magnesium is ready to lose 2 electrons to attain nearer inert gas, that is neon electronic configuration. Magnesium is loses 2 electrons. Magnesium is loses 2 electrons and form Mg2 plus ion. It formed Mg2 plus. Next, observe, let us another third A group elements. Let us observe third A group element. Example, aluminium. Example, aluminium. The electronic configuration of aluminium is like that. Its atomic number is 13. Its electronic configuration is 2, 8, 3. Aluminium ready to lose 3 electrons. Ready to lose 3 electrons to form inert gas configuration. Inert gas configuration. The inert gas configuration general formula is NH2 NP6. To form like this configuration, aluminium is readily loses 3 electrons and form inert gas configuration. It forms Al3 plus. It forms Al3 plus. Next, you observe next fifth A group element nitrogen. Nitrogen. Okay, it is number is 7. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. If you have any doubt, you can recall the number of atom or check with Euler diagram and write your configuration for sake of you children. Okay, let us observe the electronic configuration of nitrogen 1s2, 2s2, 2p, 3. Okay, it is ready to lose here also ready to lose or gain electron to form inert gas configuration. Okay, let us observe 6th A group electronic configuration. Let us observe a 6th A group electronic configuration. Sixth A group configuration. Oxygen. Its electronic configuration is 1s2, 2s2, 2p, 6, 2p, 2, 2p, 2. Here 6, 8, 4. Observe children, 2 plus 2, 4, 4 plus 4, 8. Electronic configuration of oxygen is 8. The atomic number is also 8. Okay. Here, observe oxygen 1s2, 2s2, 2p, 4. Oxygen wants to try to gain 2 electrons to become nearest inert gas configuration of neon. Here, observe 1s2, 2s2, 2p6 is the nearest neon electronic configuration. That's why oxygen is try to get or try to gain 2 electrons to form nearest inert gas configuration, and it try to gain 2 electrons and to form nearest inert gas, that is it become oxygen minus, it attains -2. Next example, fluorine. Its electronic number or electron number is 9. Electronic configuration is 2, 7. For fluorine, it remains only 1 electron to attain nearest inert gas. That's why fluorine wants to take 1 more electron to form nearest inert gas configuration. Okay, from these observations are made by Lewis. From these observations are made by Lewis, and he denoted Lewis dotted structure. He denoted Lewis dot structure, that is helium. In valence shell, electrons are denoted is a dotted form in helium. For example, hydrogen. Hydrogen has only one electron. One electron is in outermost. That is why here we denoted as like this. You use into mark or into or dot mark for Lewis structure. You use into or cross mark or dot for Lewis structure. Here we observe helium, hydrogen like this. Neon, eighth in outermost shell. That's why I will put 8 dots for neon. Argon also contain 8 electrons in its outermost shell. 8 electrons in its outermost shell. That's why I will write 8 cross marks around the argon. Like this, Lewis dotted structure denotes. Next interesting topic, children. Are you able to follow? Write down key points of this chapter to recall them easily and understand easily. When you are going to write exam, you just watch the key points of those important lesson. You easily can recall these points also. Okay, next electron valence theory. Next electron valence theory. Valence electrons are responsible for in formation of chemical bond. Okay, let us discuss one more point. In first year group element, second year group element, third year group element. Example for first year group element: sodium, potassium, rubidium, cesium, like this. Here you observe second year group elements: magnesium, calcium, strontium, barium, strontium, barium, like this. Third year group elements. For third year group elements, aluminium, gallium, indium, titanium. Okay, here 8 year group elements, that is neon, argon, krypton, radon, xenon. These are 8th year group elements. Here we observe 6th year group element: oxygen, fluorine, bromine, iodine. Like 6th year group elements: nitrogen, phosphorus. Okay, here you observe first year group elements, third year group, second year group elements. Third year group elements are released or electron is ready to remove from their electronic configuration and form nearer inert gas configuration. They are ready to give electron to another atom. These are all metals are give one electron to form inert gases. And sixth year group, seventh year group elements, fifth, sixth, seventh year group elements are gain electron to form nearest inert gas configuration. Here, metals are due electrons readily for to form nearest inert gas. Here, non-metals are gain electrons to form nearest inert gas configuration. But 8th year group elements, the magic configuration. They are neither gain nor loses electrons. Neither gain or loses electron. They are highly stable because of they undergoes few reactions, not much as not or otherwise no reactions are undergoes. Okay, let us observe about let us observe electron valence theory. Let us observe electron valence theory. Okay, electron valence theory means the valence shell electrons are responsible in formation of chemical bond. Formation of chemical bond. Here, in let us discuss it. Valency electrons of atom are revolving around the nucleus in outermost shell. Another atom also containing nucleus and electrons in shells. Their outermost electrons also on outermost shell. They are undergoes to chemical bond and forms chemical bonds, and they are responsible for chemical bonding. Valence electrons are responsible for chemical bond. Okay, here bond formation is occurred due to due to positive ions or negative ions. In both of positive ions and negative ions, there is an attraction force. Because of this electrostatic attraction force, chemical bond is formed. Because of this attraction force, chemical bond is formed. Let us discuss about ionic bond. Here, so many chemical bonds are there. For 10th class syllabus, we have discussed about two chemical bonds, that is ionic bond and covalent bond. You have two bonds, that is ionic bond and covalent bond for your 10th class textbook. Okay, let us discuss first about ionic bond. Ionic bond. This ionic bond is proposed by Cosell, scientist. The ionic bond is that transfer of ions. That transfer of ions takes place between two opposite charged, that is positively charged ions is there and negatively charged ions is there. When they are close to together, the attraction force, that means electrostatic force, is there. Due to that, the chemical bond is formed. That's why here so many compounds or molecules are formed. Let us to understand the ionic bond, you take some examples for ionic bond. First, you take the formation of some elements. For examples for ionic bond. NaCl, commonly called as NaCl, is common salt. We used common salt in our homes. Okay, here one doubt is arising for me. Take NaCl and it can vibrate. Are you dividing NaCl into Na plus and Cl minus? No. Okay, I will shake fastly with vibration of particles of NaCl. Here you can separate Na plus and Cl minus. No, we can't separate the ions Na plus and Cl. With some rare conditions in laboratory we can divide, but in case of free nature we can't divide like that. Okay, here observe the formation of NaCl. Here you observe formation of NaCl. Na, that means sodium. Sodium electronic configuration is, here you will tell just for 10 minutes before. 281. Electronic configuration of sodium is 281. Here sodium is ready to give one electron to chlorine. Chlorine has atomic number is 17. 17. Chlorine has one electron is sufficient to form octet inert gas configuration. That's why chlorine ready to gain one electron. Sodium is ready to give one electron to fluorine. Not fluorine. Chlorine. So here bond is formed between sodium and chlorine. From this sodium chloride is formed. Okay, we can write neatly with electronic configuration. Sodium electronic configuration. Write 1s2, 2s2, 2p6, 3s1. 1s2, 2s2, 2p6, 3s1. Like that. Chlorine configuration. Chlorine configuration 17, 1s2, 2s2, 2p6, 3s2, 3p5. Here, observe children, here 3s1. One electron is ready to give to chlorine. Here, chlorine is ready to take one electron. Here, the bond is formed between Na plus and Cl minus. NaCl. Here, you observe the configuration of Na. Sodium electronic configuration is 2, 8, 1. It is ready to give one electron to chlorine. Here, I will write electronic configuration for your clean observation. Write down children 1s2, 2s2, 2p6, 3s1. Like that, fluorine atomic number is 17, 1s2, 2s2, 2p6, 3s2, 3p5. Observe children, sodium is ready to give one electron to attain nearest inert gas configuration. Like that, fluorine also to gain one electron to attain nearest inert gas configuration, that is n square np6. To attain this configuration, the sodium is ready to give one electron and chlorine is ready to gain one electron. Here the chemical bond is formed due to transfer of ions. Chemical bond is formed. This is example for ionic bond. Let us observe another more example for ionic bond. Another example, MgCl2. MgCl2. Here, in this molecule, magnesium is 1, chlorine atoms are 2. Here, magnesium electronic configuration is like this. EC means electronic configuration 2, 8, 2. 2, 8, 2. Like that, chlorine configuration, just we write 2, 8, 2, 5. Here, magnesium is ready to give 2 electrons in its outermost shell to form inert gas configuration. Here, chlorine is ready to gain 2 electrons to form here. Here 6, sorry children. Here chlorine is ready to gain 2 electrons. Here bond is formed between magnesium and chlorine. This is also example for ionic bond. Take another example for ionic bond is Na2O. Here sodium, already we learned electronic configuration of sodium 2, 8, 1. Oxygen 2, 8 and 2, 6. Here, observe children, this is ready to give one electron. Sodium give one electron. Another sodium has also like this configuration 281. Here, another sodium is also ready to give another electron to oxygen. Oxygen gains 2 electrons from one sodium to 1, another sodium to 1. Here, the chemical bond is formed. This type of bond is also example for chemical bond. Let us observe another example. AlCl3. AlCl3. Aluminium trichloride. Here also aluminium. Here aluminium is also ready to give 3 electrons. Chlorine take 3 electrons. That's why here chemical bond is formed. This is also ionic bond. Okay, I will write aluminium electronic configuration 2, 8, 3. Aluminium is ready to lose or give 3 electrons. Chlorine take ready to take 3 electrons. For each chlorine, take 1 electron and form nearest electronic configuration or objective electron configuration. Here also AlCl3 is formed. It is also ionic bond. Formation is ionic bond. Okay. Here the chemical bond and electron loses somewhat ions use, some ions take, some atoms give electrons, some atoms give take electrons, some are loses, some are gain. Okay, losing of electrons form cation form cation. Gain of electrons form anion. Anion. Here, loss of an electron forms anion. Gain of electrons form anion. Okay, here some factors are depend to formation of a chemical bond, that is electron atomic size, ionization energy, ionization potential, electronegativity and electropositivity. These are all factors influence for the formation of bond. Okay, let us discuss about covalent bond. Covalent bond. Already you learn about ionic bond, the transfer of electrons between two oppositely charged and form ionic bond. Here there is no transfer of ions, that means positive ions or negative ions, that may be electrons, or in covalent bond there is no transfer of ions. Here in covalent bond the sharing of electrons is there. The sharing of electron between two atoms then forms covalent bond. Okay, for understanding of covalent bond, let us observe some examples for covalent bond. First, fluorine. First, formation of fluorine. F2. Fluorine atomic number is 9. Its electronic configuration is 1s2, 2s2, 2p5. Okay, we observed Lewis dotted method. Here 1s2, 2s2, 2p5. 5 plus 2 7, 7 plus 2 9. Okay, in outermost shell of fluorine it contains how many electrons? 7 electrons. How many electrons? 7 electrons. I will represent it in Lewis dotted structure 1, 2, 3, 4, 5, 6, 7. Like that, another fluorine atom is also there. It forms 7 electrons in their outermost orbit. It is represented in crossed marks 1, 2, 3, 4, 5, 6, 7. Okay, here fluorine atom, both fluorine atoms are come nearer the sharing of electrons takes place. Such type of bond is known as covalent bond. Such type of bond is called covalent bond. Here, the bond is formed between these two electrons. Bond is formed between these two electrons. Okay, this is one fluorine atom. This is one fluorine atom. Here, bond is formed between these two electrons. Okay, in this, electrons are not transferred, but these electrons are shared by two fluorine atoms. That's why here is formed covalent bond. Here we take another example. Fluorine 1, 2, 3, 4, 5, 6, 7. Another fluorine 1, 2, 3, 4, 5, 6, 7. Here is bond formed. Okay, let us observe oxygen. In oxygen also, covalent bond is there. In oxygen, covalent bond is there. Oxygen electron configuration to 6. In oxygen, in outermost shell, there is a 6 electrons. 6 electrons. 1, 2, 3, 4, 5, 6. Plus oxygen O2. Another oxygen also contains 1, 2, 3, 4, 5, 6 electrons in outermost shell. Here, bond is formed between these two electrons like this. Oxygen 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. Here is covalent bond is takes place. Here is covalent bond is takes place. Here observe double bond is takes place between two oxygen atoms. This is the example for covalent bond. This is the formation of oxygen molecule. Take another example, nitrogen. N2. Nitrogen electronic configuration is 2, 5. 2, 5. In nitrogen, in outermost shell, there is a 5 electrons. Observe 5 electrons. 1, 2, 3, 4, 5. Like that, another nitrogen also contains 1, 2, 3, 4, 5. Here, nitrogen 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here, transfer of electrons 3 sets. Here, 3 electrons are transferred like this. 1, 2, 3, 4, 5. Here, nitrogen 1, 2, 3, 4, 5. Here, triple bond is formed between nitrogen molecule. Triple bond is formed between nitrogen molecule. Let us observe here. These examples are all same diatomic molecules. N2, O2, like that. Here we observe CH4. CH4 methane. CH4 methane. Let us observe. CH4. Here, one carbon atom is there. 3 hydrogen atoms are there. Here, carbon has how many electrons? 1s2, 2s2, 2p2. Okay. Here, let us check hydrogen, helium, lithium, beryllium, boron, carbon. 6 atoms are present in carbon. In outermost shell of carbon, the electrons are how many electrons? 4 electrons is there. Carbon contains 4 electrons. 1, 2, 3, 4. Like that, hydrogen atomic number is 1. It contains only one electron in hydrogen atom. Hydrogen 1, 2, 3, 4. 4 hydrogen atoms containing 4 electrons. Each one of each hydrogen. Each one, each hydrogen. Here, bond is or sharing of electrons takes place between CH4. One electron, sharing of electron, sharing of electron, sharing of electron. Like that, CH4 is formed like this. 1, 2, 3, 4 electrons of valence electrons of carbon, 4 electrons of hydrogen. 4 electrons of hydrogen. Like this. Here CH4 bond formation is like this. Take another more example, that means ammonia. Ammonia formula is NH3. Ammonia formula is NH3. In ammonia, one nitrogen is there, 3 hydrogens are there. One nitrogen and 3 hydrogens are there. Okay, what is the electronic configuration number of nitrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen? You are familiar with electronic number, that means atomic number of 30 element. It is must and should necessary for you children. That's why you learn first 30 elements. Here, nitrogen has 7th hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen is 7th element. That's why it contains 7 electrons. In outermost shell, 1s2, 2h2, 2p3. 2p3. Here, 3 electrons is present in nitrogen. 3 electrons present in nitrogen. Nitrogen wants to attain nearest inert gas configuration. It attains or it waits for 3 electrons to take 3 electrons from another atom. Okay, let's observe hydrogen. Hydrogen electronic configuration is 1s1 because of it is a first element. That's why it contains only 1 electron. So that's why the electronic configuration of hydrogen is 1s1. Okay, here 3 hydrogens are there. That's why 1s1, 1s1, 1s1. Okay, a nitrogen for nitrogen contains or nitrogen required 3 electrons. The hydrogen atom or element ready to transfer 3 electrons to nitrogen. Nitrogen ready to give 3 electrons to each one of hydrogen, 1 electron to each of hydrogen. Here transform, here sharing of electrons takes place, not transfer. Here sharing of electrons takes place. That's why here bond is formed. Here bond formation is covalent bond. This is example for covalent bond. Okay, here nitrogen contains 3 electrons in outermost shell. 1, 2, 3. Observe children, bond is too congested, but our situation is like that. Hydrogen contains 3 electrons. 1, 2, 3. Here bond formation takes place. Here bond formation takes place between these 3 electrons and these 3 electrons. Formation of NH3 is like this. Like this, bond formation takes place in ammonia. These are all examples for covalent bond. These are all examples for covalent bond. Okay. Next, Westphal theory. Westphal theory. Next, Westphal theory. Okay, let us going into the Westphal theory. We can observe formation of nitrogen and oxygen by hybridization. Okay, let us observe the formation of oxygen and nitrogen. Okay, first we observe nitrogen. Just you go recall electronic configuration of nitrogen to 5. To 5. Here, one nitrogen contains 7 electrons. Another nitrogen is also contains children For your understanding purpose, I will write like this. This nitrogen wants to one electron. This also wants to one electron to bond formation. Okay, we will write electronic configuration of nitrogen is 1s2, 2s2, 2p, here 7, here 4, 5, 6, 7, 3. Another nitrogen also contains 1s2, 2s2, 2p, 3. Here observe children, there is a electron, outermost electron in p orbital. Here also outermost electron is in p orbital. Then here outermost shell is responsible in chemical bond formation. Here p orbitals are overlapping in this bond. P orbitals are overlapping. Observe children. Like this, antimolecule is formed. Here we will observe p orbital. 1 electron, 2 electron, 3 electrons is there. Here also in p orbital 1, 2, 3. Px, Py, Pj. 1 electron in Px, Py, Pj. Px, Py, Pj. These are overlap and form N2 molecule. This is the example for pp orbital. This is example for p orbital and p orbital overlap. Okay, let us observe another, one more example. Next, oxygen. Next, oxygen molecule. Okay, oxygen contains 8 electrons. Okay, let us observe oxygen electronic configuration 1s2, 2s2, 2p, 4. Here also, outermost shell or electron is in p orbital. Like that, another oxygen molecule also contains 1s2, 2s2, 2p4. Here also 8 electrons are present in outermost shell. 8 electrons are present in oxygen. Here also 8 electrons are present in this oxygen. In outermost shell, there is a 4 electrons is present in p orbital. Here also 4 electrons are present in outermost orbital. Here p orbital electron distribution is like here. The remaining lone pair of electrons are formed or participate in bond and form oxygen molecule. Oxygen molecule. This is also overlapping of pp orbital. Then observe another overlapping for s and p overlapping. Okay, HCl. Observe HCl. Hydrogen contains only 1 electron, that means 1s1. Hydrogen contains 1 electron. Hydrogen electronic configuration is 1s1. Okay, let us observe chlorine. Chlorine has 17. The electronic number of chlorine is 17. Write the electronic configurations of chlorine also. 1s2, 2s2, 2p6, 3s2. Count children, 4, 10, 12. 3s2, 3p, 10, 5. 3p, 5. Here, chlorine wants to gain 1 electron to form octet configuration. That's why chlorine takes hydrogen or electron and form the bond. Here is the formation of bond is ionic bond. Anyway, here outermost shell electron is present in s orbital. Here, outermost electron is present in p orbital. Here, hydrogen contains one electron. Here is chlorine contained in outermost electron in p orbitals. There is a overlap between p orbital and s orbital. There is an overlap between p orbital and s orbital. This is the example for s and p overlapping. Overlapping. Okay, next SS overlapping. Example 1. Wait. SS overlapping. Take hydrogen. Hydrogen 1s1. Another hydrogen is also 1s1. Here, electron is present in s orbital. Here also, outermost electron is present in s orbital. There is a 2s orbital overlapping. The formation of H2 molecule by SS overlapping. Here we discussed about valency shell repulsion theory. Valency shell repulsion theory. This is also called as Vesper theory. Vesper with joy. Here, Vesper theory means valency shell electron repulsion electron pair repulsion theory. For explaining the shape of orbitals and bond angles of orbitals is described by Vesper theory. Here, bond takes place in covalent bond where 2 or 3 or more than 3 molecules. The lone pair electrons, the repulsion of lone pair electrons, the shape of the molecules is changed. That's why the bond angle is changed. For Vesper theory, examples are BeCl2, and BF3 and CH4. These molecules are all example for NH3 also. NH3. These are all shapes and structure depends on Vesper theory. Let us observe these examples. Let us observe these examples. Okay, BeCl2. First, BeCl2. Okay, Nana, beryllium. What is the electronic number of beryllium? 4. Hydrogen, helium, lithium, beryllium. 4 is the atomic number of beryllium. So, electronic configuration of beryllium is 1s2, 2s2. Okay, chlorine 17. 1s2, 2s2, 2p6, 3s2, 3p5. 4 plus 2, 8, 8 plus 2, 10, 10 plus 2, 12, 12 plus 5, 17. Here, the bond is formed BeCl2. Here, observe chlorine atoms, 2 atoms. Each one chlorine bonds to 1 electron. For 1 electron. Here, chlorine takes 1 electron from Be and another chlorine takes from Be another electron. Here, bond formation is like that. In beryllium, 2 electrons. 1, 2. Here, chlorine 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Another chlorine also 5 electrons. 1, 2, 3, 4, 5. Here, bond formation. Here, it takes 1 electron. It also takes another electron. Here, bond formation is takes Cl. Here, bond angle of BeCl2 is 180 degrees. Here, bond angle is 180 degrees. Let us observe boron trifluoride. Let us observe boron trifluoride. Boron electronic number is 5. It contains 1s2, 2s2, 2p1. Here electron number is 5. Here observe children, 1s2 contains 2 electrons, 2s2 contains 2 electrons, 2p1 contains 1 electron. Like that, fluorine has a ninth molecule. It contains 9 electrons, 1s2, 2s2, 2p5. Here observed 5 plus 2 7, 7 plus 2 9 electrons is there. In boron, 1 lone pair electron is present. In fluorine, 5 electrons are present in outermost shell. Here fluorine wants to 1 electron to attain inert gas configuration. Here boron 1, 2, 3. 3 electrons is there. 1, 2, 3. Here fluorine 5. 1, 2, 3, 4, 5. Fluorine 1, 2, 3, 4, 5. Here fluorine 1, 2, 3, 4, 5. Here bond is formed like this. Here BF3 is formed. BF3 molecule is formed like this. In BF3, bond angle is 120 degrees. Bond angle is 120 degrees. Another example, we will take that means methane. Example is methane. CH4. Carbon atomic number is 6. It contains 6 electrons. 1s2, 2s2, 2p2. Here 2 plus 2 4, 4 plus 2 6 electrons is there in carbon. Okay, 2 electrons in p orbital. Like that, hydrogen contains 1s1 each of hydrogen. Here 4 hydrogens are there. Okay, carbon contains 4 electrons in valence shell. 1, 2, 3, 4. Here hydrogen has 1 electron from each hydrogen. 1, 2, 3, 4. Like that. Here lone pair rule, because of Westport theory, the shape of methane is like this. The shape of methane is like this. Here bond formation is formed in this. The bond angle is 109 degrees. Bond angle of methane is 109 degrees. Next observe last example, ammonia. Next observe last example, ammonia, NH3. NH3. Okay, next ammonia, nitrogen. The electronic configuration of nitrogen is what is the atomic number of nitrogen? Nitrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen atomic number is 7. So it contains 1s2, 2s2, 2p3. Electronic configuration is like this. Here there is a 3 electrons in outermost shell. Okay. Nitrogen electrons 1, 2, 3, 4, 5, 5. Here hydrogen 1s1. Electronic configuration of hydrogen is 1s1. Here 3 hydrogens are there. 1s1. Each hydrogen contains 1 electron in the outermost shell. Here 1 hydrogen, another hydrogen and another hydrogen. Okay, then bond formation is like that. Hydrogen with 1 hydrogen, bond formation is like that. Here also 1 hydrogen with 1 electron, bond formation is like that. 1 electron, 1 hydrogen atom with bond formation is like that. Here 1 lone pair of electrons is present the nitrogen. This is the bond formation in NH3 molecule. Let us observe another and last example, that is water molecule H2O. This is most necessary for living of our human beings. Okay, hydrogen, two hydrogen consist, one oxygen is there. Hydrogen consists one electron, 1s1. Another hydrogen is also 1s1. It attaches to gain one electron to attain nearest helium electronic configuration. Okay, oxygen is 8. 1s2, 2s2, 2p. Fourth, it wants to 2 electrons from their neighbor or nearer atom to form nearest enough gas, that is neon electronic configuration. Here, the sharing of electrons takes place between H2 and O, then form the water molecule. Okay, hydrogen electron with one electron, another hydrogen with one electron, oxygen with outermost shell 6 electrons is there. 1, 2, 3, 4, 5, 6. Here, bond formation. Let us observe oxygen 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, hydrogen 1 electron, hydrogen 1 electron. Here, bond formation is takes place. Here, I will go right here to observe. Here, bond is formed like this: oxygen, hydrogen, hydrogen, lone pair of electron. The bond angle is attached. This is the shape of and bond formation in water molecule. Okay, children. Today we are discussing briefly about the chemical bond lesson. Briefly about chemical bond lesson. In this chapter, we learn about ionic bond, covalent bond, Westphal theory, that means valency shell, electron pair, repulsion theory, and examples, bond angle, hybridization, and electronic configurations, and shape of the molecules. These are all important for your public examination. More chances are given for essay questions. The formation of oxygen molecule, write the formation of oxygen molecule, and question like this, write the formation of nitrogen molecule, and what is the bond angle, what is the shape of NH3 H2O. Like this questions are raised. So concentrate, please concentrate more effective, more interest on chemical bond for sake of your examination. Thank you for giving this opportunity. Thank you, children. Thank you.